In this section, we're going to discuss the comparable interface as an example of any interface. Many interfaces exist that add some capability to classes. We mix in the interface, implement the defined methods, and that class then is a subtype of the interface and can do whatever the interface defines. Not every class in an inheritance hierarchy may mix in the interface. If any superclass mixes it in, all subclasses inherit it. Now, on rare occasions, there are interfaces called marker interfaces that have no methods defined. They're simply meant to specify a piece of type information so that if class implements it, that class is of that type. The comparable interface is of the first variety, that where we have some method defined that will have to have some behavior implemented. It adds a method named the compare to, which allows external code to call that compare to method to do sorting. Comparable means that two objects of a given class are comparable in some way to determine which orders first and which orders second of the two. There's some relative order. For numeric values, that's easy. The smallest value orders first, the largest value orders second. But non-numeric data types cause a little bit of thought to have to occur, because what does it mean to be less than another object? The compare to method is always invoked on an object of a class and past a parameter of a different object of that same class or a supertype. The result of compare to is a numeric value. The value itself rarely has meaning. Rather, its sign has significance. If it's negative, it means that the object on which the method was invoked, not the parameter, orders first. If the value is 0, it means they're equal, and that's where the value does matter. And if the result is positive, it means the parameter orders first, the object second. It may help to consider the invoked object as a point on a number line. If the compare to method on the invoked object returns a negative value, if the invoked object, that the object itself, not the parameter, is in a more negative or left direction, meaning that the object orders before the parameter. If the invoked object is greater, then the return will be positive. That means that the parameter orders on the more negative direction, the invoked object more positive direction to the right. It means it orders second, the parameter first. And of course, if they're equal, the value is 0, and that means they're the same object or they contain the exact same data. For non-numeric values, it may take a bit of thought to determine what is equality, what is less than, what is greater than. That's something that each problem will tend to dictate based on the data that's being manipulated in the objects.